Hello everyone, my name is Lisha Dsouza, Assistant Professor, Department of Medical Laboratory Technology, Yenepoya School of Allied Health Sciences. Today I'll be talking on paper chromatography. Paper chromatography is one of the well-known separation technique used in different fields such as in biochemistry, forensic science, environmental science, etc. Before starting, let's move on to the specific learning objective. At the end of the session, participants should be able to describe the principle and factors affecting paper chromatography, explain the procedure of paper chromatography, describe the applications of paper chromatography. Moving on to the history of chromatography, Michael Sweat is named as the father of chromatography. He was a botanist who came up with this theory. He used this method to separate the plant pigments. Over the years, there are different chromatographic techniques came into existence, such as paper chromatography, thin layer chromatography, affinity chromatography, high performance liquid chromatography, etc. Paper chromatography was invented by Richard Lauren and Archer John Porter. They first developed and described this technique in 1943, for which they have also won the Nobel Prize. So, paper chromatography is considered to be the simplest and the most widely used chromatographic technique because it's easy application, identification, and quantitative determination of organic as well as the inorganic compounds. Coming to the principle of paper chromatography, there are two phases. One is the stationary phase and the other is the mobile phase, which is both are liquids. The stationary phase is water immobilized around the cellulose granules of the filter paper. The mobile phase may be organic solvent which is saturated with water. The sample mixture can be separated based on the difference in the partition coefficient. Types of paper chromatography. It is carried out mainly by the flow of the solvent on specially designed filter paper. We have two types of paper chromatography. One is paper adsorption chromatography and the other is paper partition chromatography. Coming to the paper adsorption chromatography, in this the paper is coated with silica and alumina which acts as an absorbent, which is a stationary phase, and the solvent which is used is a mobile phase. In paper partition chromatography, the moisture and the water which is present in the pores of the cellulose filter paper acts as a stationary phase and another mobile phase is used as a solvent. Coming to the steps of paper chromatography, we have various steps. Coming with the starting one is a stationary phase, application of the sample, mobile phase, development technique, and detecting or visualizing agents. Stationary phase, we use Whatman filter paper of different grades. Choosing of the grades is depending upon the sample and the solvent nature, based on the qualitative and quantitative analysis we do, and based on the thickness of the paper. We use Whatman filter paper grade number 1. Preparation of the filter paper. A rectangular Whatman number filter paper is taken. The length should be around 15 to 30 centimeter and the breadth has to be 1 to 5 centimeter. From the bottom, we have to mark 5 centimeters and we have to draw a horizontal line. Cross mark is drawn on the horizontal line with a space of 1.5 centimeters apart. The cross mark coincides with the number of samples compound to be resolved. Application of sample. Very less sample has to be applied. It can be applied with the help of a capillary tube or a micropipette. Very low concentration is used to avoid larger zone. The spot is dried on the filter paper and then it is placed in the developing chamber. Preparation of solution. Choice of suitable solute for making solution is very important. If it's a pure solution, we can directly apply it, but if it's in a solid form, it always has to be dissolved, and then a small quantity of suitable solvent is added. Like for example, for amino acid, we use 1% amino acid. We prepare it by 1 gram of amino acid dissolved in 100 ml of 1 normal sodium hydroxide. Coming to the mobile phase, we can use two types, that is hydrophilic mobile phase and also hydrophobic mobile phase. In hydrophilic mobile phase, we have isopropanol, ammonia, water in a ratio 9:1:2. We have methanol and water in a ratio 4:1, and butanol, glacial acetic acid and water in a ratio 4:1:5. Hydrophobic mobile phase, we have dimethyl ether and cyclohexane, kerosene and 70% isopropanol. Chromatographic chamber. The chromatographic chamber is made up of different materials such as glass, plastic or stainless steel. Glass is the choice of material used for the chromatographic chamber. The chambers come in different sizes. Before placing the filter paper, the chamber has to be saturated with the solvent vapor. Before adding the filter paper into the chamber, we are supposed to saturate the chamber with the solvent vapor. So we add the solvent into the chamber and we keep it for some time. Later, the paper is immersed in it. So the paper is flexible as compared to the glass plate used in thin layer chromatography. The paper is dipped in solvent in such a manner that the spots will not dip completely into the solvent. As mentioned prior, we are supposed to have a 5 centimeter distance and we draw a horizontal line. While placing the filter paper into it, we should make sure that this line drawn on which the sample is applied does not dissolve in the solvent. The solvent will rise up as it allowed to run 2/3 of the paper height for better efficient results. A propelling force is developed which drags the sample in the direction of the solvent flow. As the solvent moves forward, the sample also moves along with it. The compound with the greater solubility in the solvent moves rapidly, while that with lesser solubility moves slowly. The process of partition is also responsible for separation. Partition of the substances occur between the mobile phase and the stationary phase. The distance traveled by the solvent is called as the solvent front. This is always approximately 2 centimeters from the top edge. Coming to the types of development, the spotted paper is developed by different methods such as ascending development, descending development and disc development. Ascending development, a solvent tank is filled with a suitable solvent depending upon the solute to be resolved. The spotted paper is vertically immersed into the solvent with the spots always lying above the solvent levels. As you can see in the picture, the spots are above the solvent level. It moves upwards. The solvent travels vertically upwards by the capillary action. Coming to the descending development, it is carried out in a special chamber where the solvent holder is at the top. The spots is kept at the top and the solvent flow down the paper. So you can see the difference between the ascending and descending. Here in ascending you have the solvent below and it vertically moves upwards, whereas you can see the descending chamber, it's a special chamber where the solvent is present on the top and the paper is attached to it, whereas it moves downwards. One advantage of descending chromatography over ascending chromatography is that the movement is faster and we get the results quite early. Disc circular radial development. So the paper is cut in a circle and pencil marks are drawn. The circular paper is called as a disc. Spot is kept at the center of the circular paper. A wick is cut from the edge of the center of the disc. The disc is placed on the solvent taken in the Petri plate. The solvent flows along with the wick and reaches the sample and drags radially outwards. As you can see in the picture, we have a circular filter paper and we have a Petri dish in which we put the solvent and we place the circular cut filter paper into it, having a wick at the in between, and in a circular manner we place the sample. Two-dimensional development. In this method, the paper is developed in one direction, and after development, the paper is developed in the second direction, allowing more compounds to be separated into the individual spots. In the second direction, either same solvent or the different solvent system can be used for the development. In two-dimensional development, as seen in the picture, first we let the paper run with one solvent, then we change the solvent and we turn the paper to 90° clockwise and let it run for few more hours. After the run is completed, next procedure is the drying of the chromatogram. The paper is dried by cold or hot air depending upon the volatility of the solvent. Dried paper with the solvent front is called as the chromatogram. For the drying, we can use a simple hair dryer or also we can use a hot air oven. Detecting visualizing agents. So few substances are colored, so they are visibly detected easily. For colorless substances, physical and chemical methods are used to detect the spots. So we can use the physical methods such as we have iodine chamber and UV chamber. Chemical methods, we have ferric chloride for phenolic compounds and ninhydrin in acetone for amino acids. After spraying the visualizing agent, the paper is dried and the spots appear. RF value, retardation factor. In paper chromatography, the results are represented by the RF value, which represent the movement of the migration of solute relative to the solvent front. So the formula for RF value is distance traveled by the solute divided by distance traveled by the solvent. As you can see in the picture, we have A, which is the distance traveled by the component, and the B, which is the distance traveled by the solvent. So RF value is equal to the distance traveled by the component and divided by distance traveled by the solvent. Factors affecting RF value. Different factors can affect the RF value, such as the temperature, the purity of the solvent, the quality of the paper, the saturation of the chamber, and the drying technique. The distance traveled by the solute and the solvent, chemical reaction between the substances being partitioned, and the pH of the solution. Coming to the applications of paper chromatography. Paper chromatography is a versatile separation technique used in different fields. It is used in the separation of mixtures of drugs, separation of carbohydrates, vitamins, antibiotics, proteins, etc. It is used in the identification of drugs, identification of impurities, analysis of metabolites of drugs in blood, urine, etc. Summary. Paper chromatography is a technique which is used to separate and identify mixtures based on their interaction with stationary phase and mobile phase. There are two phases of paper chromatography, that is paper partition chromatography and paper adsorption chromatography. The development technique of paper chromatography are ascending chromatography, descending, and circular. Paper chromatography is used for identification of carbohydrates, proteins, amino acids, drugs, etc. Thank you.